Jensen Huang is here. He is president, CEO, and co-founder of Nvidia, the world's largest producer of graphic chips. But Nvidia is a lot more than powering high-end video games for PCs. Visual computing is revolutionizing many aspects of our lives, from smartphones and handheld computers to medical scanning equipment and energy exploration. Jensen Huang has been on the frontier of this process. I am pleased to have him here at this table for the first time. Welcome.
Thank you, Charlie.
What is it that you and your company contribute to the world that all of us interface with? Computers, phones, medical, graphics.
Well, we invented a product called a GPU, the Graphics Processing Unit. And this technology, along with all the software that we produce for it, makes it possible for you to see information, see the world in a way through the computer that wasn't possible. And so we could create imaginary worlds for you to be part of. We could make it possible for you to go to a different country and surf the world through Google Earth, and we can help you see objects in a way that wasn't possible
Google Earth,
before.
which lots of people know about.
Yeah.
How do you figure in? How does your processor connect to them?
And so what they do is there's a database of height maps and a database of textures of different countries and different lands and different spaces, and this is all part of a database that's at Google. What our technology does is take all of those images and three-dimensional data and render it through the computer screen so that what the user sees looks like a 3D image of the world. And so we take a bunch of numbers and a ton of data, terabytes and terabytes of data, and we make you imagine you're seeing the world.
Take us to where you are and what you're doing today, and where you might be 10 years from now. Where is this sort of the excitement?
Well, if you take a look at what the GPU has really done for the computer today, the breadth of applications is really, really astounding. People see us as one of as the guys that bring the technology of video games to you, and the reason for that is because the video game market, which 15 years ago I postulated was going to be a killer app, and 15 years ago when I started Nvidia, the video game market was approximately zero. It was a little tiny company, little tiny industry, and Electronic Arts was a little tiny startup,
yes.
and now today it's one of the largest global entertainment industries, and so people associate us with video games, and that's fabulous. We're bringing these virtual worlds to people, and we create these this alternative universe that people can't imagine, and is wonderful and is exciting. But we have a whole different part of our business where visual computing and the GPU has enabled all kinds of capabilities, whether it's in the discovery of energy, the amount of seismic information that comes out of the Earth, and the difficulty of finding those oil reserves has become so difficult that you really need to be able to render that image in a massive, massive screen. I mean, these are the world's largest power walls, and they're, many, many megabytes of pixels that are on the screen, and the amount of data behind it is just, hundreds of gigabytes. And a scientist needs to go find that oil reserve. It could be a doctor who has taken these CT scan data and is looking for cancer or tumor, and is surfing through your human body so that they could find a tumor a little bit more carefully, more precisely. And so whether it's, or even the next generation Audi that's coming out where our GPUs is making it better for you to navigate, and the instrumentation is going to be powered by our GPUs, to the F-22 Raptor. There are 6 of them inside the most modern pilot,
right.
Yeah, so that the pilots could see the enemy a lot more quickly and clearly. And so, whether it's from changing lives to saving lives,
now,
our chips are in those industries.
Are these things that you and your company are creating for these people? In other words, do you see the need, and so therefore, in an entrepreneurial and a creative way, you make the product? Or do people in need come to you and say, is it possible to do this with your GPU? Or can you imagine a GPU that could solve this problem for me?
Well, that's a good question. And it's a little bit of both. If you ask me what I do for a living,
yes.
Ultimately, what we do is we solve some of the greatest challenges of computing in the world. And so we know what our tool is, and we know what our expertise is, and we try to put ourselves in situations where people who have extraordinary challenges. It could be one of my favorite stories is a couple of doctors at Mass General, and they would like to use the GPU in a very specific way. And they had this, they learned about the GPU, and they thought, wouldn't it be great if we used the computational capability of the GPU to reconstruct CT scan data in real time, so that they could do a mammogram in real time before the patient goes home, and truly discover whether that person has cancer or not right there. Okay, and one of the challenges that they have is the amount of data they sort through is so great that there's a lot of false detections, and it scares the patient, obviously. And so if you had if you could render the woman's breast in three-dimensional volumetric precision, you could actually go through it layer by layer, and almost any novice can detect whether there's breast cancer or not. And so the computational capability was really vast, and they didn't think that it was possible unless they were to use this new device called a GPU. And so they came to us and they said, look, we would like to do this thing. The outcome of this project is likely either a paper, or we'll buy a few GPUs. And so we manufacture about 100 million a year, and here's a couple of doctors who would like to buy 2 or 3 when they're all said and done, and the project would take about a year and a half or so. We love those kind of opportunities, because it really takes us into spaces that we've never been to before. As a result of that, they published a paper. It became a huge craze in medical imaging. Now we're engaged with every medical imaging company in the world. It took us to places that we just simply didn't know. That same capability in imaging could be used for Adobe's Photoshop now, so that you could do things in digital photography that is now becoming a field called computational photography. And really exciting.
And how much of your business today is still in gaming?
Well,
or games?
I would say that call it 20% of our business, maybe 30% of our business goes towards people who are hardcore gamers, and they just, this is what they live and breathe, and they always want the latest generation technology. They want to always have the best gear. In that business, we're a little bit like Nike. We are the gear of choice of cyber athletes. They're playing games just like people were playing basketball and football, and so I think they see us kind of like a Nike. In the case of these doctors and scientists and engineers, we're probably like Silicon Graphics to them used to be. We're the company that provides
sort of the
technology.
Initial graphics company, right?
That's right. That famous graphics company in Silicon Valley that really brought 3D graphics to mainstream because of the work that they did with Jurassic Park and Terminator, and many of those engineers now work at Nvidia, and the work is very important.
A bit of biography before, because you have a very interesting life. You're how old now?
I'm 45.
You're 45 now. You started the company when you were
30.
30.
Yeah.
Before that, I mean, you kind of bounced around several states. Tell me the story. And had a learning experience that serves you well.
Well, we were in Thailand. I was just about almost 10 years old. And recently, Thailand had a coup.
Right.
Well, in 1973, they had a coup. And I think it was 1973, 75 or something like that. And my parents thought that it was unsafe for us to be there. And so my parents put my older brother and me on a plane, sent us to Tacoma, Washington, where my uncle was. From there, they put us in a private school, a boarding school, And the one that they selected, I'm not exactly sure why, but my parents didn't know the United States very well, and probably didn't know that Kentucky was very far away from Washington.
So they sent you off to school in Kentucky.
So we ended up in a small town in Kentucky called Oneida. The website's still up. It's the Oneida Baptist Institute.
Yes.
And so my older brother and me went to Oneida Baptist Institute for about a year and a half or so, and it was a fabulous experience. We were the only two Chinese kids that had been there, and this was during a time when the United States was still rather learning about foreigners, and so everybody asked me whether I knew Kung Fu, and because of Bruce Lee, and obviously I didn't, but I was very good in math, and so all of the local kids took to me because I could help them with homework and things like that. And it was a small school. My job during the afternoons after you go to school, everybody has a task. My job would be to clean all the bathrooms of the dorm. It was a dorm of about 300 kids. And my older brother's job, he was 1 year older than me, so he was 11 years old. His job was to work in the tobacco farm. And so we would do this until my parents came, and then we flew back to Washington, where we met up with them. But it was people say, Jensen, you went to a school, and it turned out that school, I'm not even too sure how they positioned the school and why we went to it, but it's a boarding school that for international students somehow. That's also a reform school. And so, I don't know how they got into that business, but it turned out there were a lot of challenging, very, very difficult and very tough kids. My roommate was 17 years old, and I still remember that when we were getting ready for bed that night, he took off his shirt and he had stab wounds all over his body. Yeah. And so it turned out to be a wonderful kid. Didn't know how to read, but turned out to be a wonderful kid, and I learned a lot in that school.
What brought you to technology?
I was in high school in Oregon, and I was very good in math, and I was very good in science, and I always felt that I was going to be an engineer. One of my best friends in high school, the small group of us were exposed to the Apple II and a terminal that hooked us up with a mainframe. Yeah. And so we played a lot of games, wrote a lot of programs, and we were exposed to the computer early on. And so
this is a similar experience to Bill Gates.
Yeah, in fact, I'll argue that's right. And when he tells that story, it really resonates with me.
Because there was a machine in his school, put there by his mother.
Exactly.
And he will argue to you, as you know, that's what turned him on, and because of all those hours, and he became, as he said, he said I was just a maniac about this to me in a recent interview. Yeah,
yeah, and I fell in love with it myself. The video games was a big part of probably the reason why he initially. In our case, the mainframe had a video game called Star Trek on it, and we could play Star Trek in basically a virtual world battleship. Yeah. You make a move, they make a move, and we would play this across the network. Well, it wasn't a network; it's a mainframe, the cloud computing of that day. And we would play against all these other kids probably, and I wouldn't be surprised if Bill was on the other side playing. Yeah.
You created Nvidia when?
1993.
And then went public in 1999.
Right. We, in fact, somebody told me that this month was actually our 10th anniversary, and so of being public. Yeah. And
so January.
Yeah.
You created the company believing you could provide what? Serve what market?
To be honest, we it's like I think all of these startups, you have an intuition. The intuition is that 3D graphics, if made in extremely high volumes, could do as a medium what video could have done, what audio did, except this particular medium is fundamentally interactive. It is different every time, very different than video. Every time you watch it, it's the same. This is a medium that you can share. If you look at one of the world's largest virtual worlds, the World of Warcraft, hundreds of thousands of people are inside enjoying that one application, that one instantiation at the same time. And they're hooking up, they're, hey, let's get online, and at 7 o'clock, let's get a clan going, we'll go attack that castle together.
Yeah.
So that's the ultimate virtual experience, the ultimate online social experience. So we imagine these type of capabilities when we started the company. And we made it high enough volume. Video games, the way people communicated, the way people learned and explored would change. And so we imagined all the things that we are experiencing today then. But how we could get here, that's something you just kind of explored along the way. We kind of felt our way here.
You've also attracted the attention of Intel. Where is this competition today, and where is it going? They make microprocessors, they do a lot of other things, but they are, Wintel was a product of Microsoft and Intel. Windows and Intel.
Mm-hmm. There's a lot of there's this tension between us and Intel that is discussed today, and I think that at the core of it, if you will, is the battle for the soul of the PC. And let me if you look at the PC was created as a electronic and technological, a general purpose version of the typewriter and the calculator. And notice the two killer apps that got us here was Word and Excel.
Right.
Okay. One is a calculator, one's a typewriter. And so the architecture of the personal computer is based around a processor called the CPU, which is optimized designed for text, characters, numbers, and number crunching. And then all of a sudden, the personal computer, and knowing that the vast majority of the world's people don't need to just write or calculate, and that the computer has made it possible for us to experience things, to go places, virtual places, to go to virtual worlds, to go to environments to share with your friends, to experience things that aren't real, that are wonderful and imaginative. The computer has become, all of a sudden today, a medium for artistic expression. And so where we started and where we are today is very different. And along the way, what happened was, and what made this possible, this virtual world capability, this experiencing the world capability, virtual worlds and imaginations and artistic expression, what makes that possible is this processor we invented called the GPU.
Right.
And so now there's this tension between which one is more important. We believe that the GPU is going to become more and more important than ever. And instead of just manipulating text and numbers, the world's going to want to manipulate images.
And what do you think Intel believes?
I think that they clearly believe that the GPU is becoming more important because one of the things that they're doing is investing, and they talk about it greatly, about the processor that they're building to be a GPU called Larrabee.
Right.
And so
they want to take you on.
They want to take us on, and so I think there's a good reason for that. And the perfect metaphor.
Okay, these are things you brought with us to show me.
Yeah, let me show you one of my favorite things. I mean, this is a full computer.
Right.
This computer here runs Windows Vista. All you have to do is add memory, and you're done. Mm-hmm. Okay, this is a little tiny computer. There are two chips on here. There's two processors. One of them is the CPU,
right,
and one of them is the GPU.
So point them out.
So here's the CPU,
right,
This is the Atom processor. It is my favorite processor in the world. It's the fastest selling processor, even through this recession. It's tiny. It's low power. It's enough performance to run almost anything you want if you coupled it with a GPU. And so this is the GPU. Steve Jobs recently, when he announced the MacBook that we're in, the MacBook Pro, he described this as an amazing chip. And he spent all this time talking about this chip. And so this processor, this GPU here, has 16 GPU processors inside and 54 gigaflops. So to put that in perspective, that's like this is what is that? 54 times faster than the fastest supercomputer the world made the year Nvidia was founded.
So in 1993, this is
right. The Cray XMP was 1 gigaflops. So this is 54 gigaflops. And so these two processors make up your PC today. And look how small it is and low power it is. This is where the computer industry is going.
What are its capabilities?
Well, you know, this particular computer is a smaller version of a modern computer, and therefore its capability is no different than any computer that that anybody can imagine. So 3D graphics, high definition video, wonderful resolution, Vista Premium, OS 10. It can run any operating system you want. And so this particular computer, what's really amazing about it is how small it is and how few devices that are left. And you know, the tension between the question that at the core of your question is really the battle of which one's more important. And
your argument is?
Our argument is that the CPU is important. You can't do without it. But where we want to take the future of computing, the GPU is going to do the job.
But can the GPU do it alone?
The GPU surely can't do it alone.
Exactly.
Yeah.
So you're just simply arguing that you need both. If you want to reach the potential of where the technology is.
That's right.
You need both a GPU and a
that's right. You need both.
CPU.
And then there's a shifting of relevance, if you will.
So, but do you envision in your most expansive moments that Nvidia has the possibility of becoming as powerful and as huge as Intel?
You know, I don't think in those terms necessarily. I think
but you have to think in terms of not so much how big we can be, but where we're going.
Yeah.
And what is the nature of it. And
that's
therefore,
exactly
how do I make sure that we have the architecture, the capital, the research, and the talent to get there?
That's right. Another way of saying exactly what you just said is what's always top of mind for me in our company is, are we working on the most relevant things to drive the industry forward, to add value to the world? You know, you notice people talk about the competition between us and Intel today, and yet we don't make a microprocessor. It's actually very interesting that people talk about the competition or tension or the relationship.
Meaning they expect you to make a microprocessor?
Here's a company we compete with, and we don't make what they make.
But they want to make what you make.
They want to make what we make, but at the moment they don't either. And so what's interesting is, you know, it's almost like Microsoft and Google. They don't make what each other's make.
Right.
But they're competing against each other. And so what's actually happening is the competition is not about the competition of the device. It's actually about
I think they both think about making what the other makes. I mean, I think in those two cases, Google thinks about what Microsoft does in terms of perhaps in terms of creating software. And I think that Microsoft thinks about what Google does in terms of creating search engines that will generate huge advertising revenues.
That's right. And even what I would add to that is what's even more scary for companies is the shifting of the relevance of the work that you do. If there's a shifting of the relevance from client computing to cloud computing,
right,
Google surely will be advantaged. If there's a shifting,
is that clear to you that cloud computing is the wave of the future?
Cloud computing would supplement client computing.
Supplement.
Yeah, supplement. You know, nothing ever kills anything else. Neither did the internet didn't destroy television.
Right.
Internet didn't destroy radio.
Television didn't destroy radio.
That's right. And so
records didn't destroy radio.
Exactly. And so clearly this is the question that the conversation we're having right now is exactly the same. The GPU won't destroy the CPU. The CPU is one of the greatest inventions of humanity.
Without the CPU, no computer.
No
personal computer.
That's right. Why reinvent it for us? What we should do is take advantage of the CPU and build upon it, stand on the shoulder of giants, and take the industry to where it couldn't have gone without our contribution. And that's why we've dedicated all of our R&D. And I'm going to, you know, during this recession, I'm going to invest more in R&D this year than I did last year.
Because
I believe in the future of the GPU.
Right.
I believe that,
in other words, you're not going to let the recession
work.
prevent you or restrict you from doing your foundation conviction that we're just starting.
That's right.
In the potential.
That's right.
Of video graphics.
The work that we're doing is just too important.
Okay. Show me what other things you have. Well, let me just say this first. So we mentioned medical imaging. We talked about that. We've talked about energy exploration. We've talked about television broadcasting. We've talked about PCs, and so therefore mobile computing is the same thing because the two are becoming, in many ways, the same. Yes.
All the experiences you have on your personal computer, you're going to have on your mobile computer pretty soon.
All the things we've talked about. What's the most exciting thing happening right now in your world? Not just your company, but the world you inhabit.
There's a few things there are several things that really excite me. You know, if you take a look at the computer today, and you compare it to a computer 10 years ago, I would say that by and large is very similar. It's very similar. The type of applications have been expanded. The reach has expanded out to the web. There's a whole new class of processors that is called a parallel computing processor, and a GPU falls into that. We have made our GPU completely general purpose so that you could use it for almost any application for number crunching. All of a sudden, the speed up, the performance that you get from a computer can increase by a factor of 10, a factor of 100. And these are the reasons why people have put NVIDIA's GPUs into supercomputers. Japan, the fastest supercomputer in Japan is located at TAITEC, the Tokyo Institute of Technology, and the name of the supercomputer is called Tsubame. And Tsubame recently installed a bunch of GPUs inside and became the 29th fastest supercomputer in the world. And so NVIDIA's GPU has made it possible for small implementations of computers to achieve performances that are really way off the chart. I think when you add that much, when something becomes 100 times faster, it changes the way software engineers think about that platform. And so GPU computing is going to have a radical impact on computing. The second area has to do with the way, not just the way we render the information onto a computer screen, but the way that we actually see the image all the way to your eyes. You know, one of the things that's really exciting to me, this is a new product that we made called 3D Vision. Right. It looks like a set of goggles, but it's electronic. There's a little computer inside right here. And what we do is, you know, if you take a look at a video game today, the screen that you have, your television screen or your computer screen, is 2D. So although it's 3D inside, it's projected to a 2D screen. So if you look at it, it's basically 2D. Okay? But if you put these glasses on, the images project all the way to your eyes, and it's projected in a way that makes you think that what we rendered on the screen is 3D, completely stereoscopic. It's like a 3D movie. If you put on those glasses, all of a sudden the movie kind of jumps out at you. It dimensionalizes it. If you ever play a video game or watch a movie with these glasses on, the experience is just radical. It's just absolutely amazing. So that's another area where I'm really, really excited. Tell me about CUDA technology. So CUDA is an architecture. We actually call it CUDA, CUDA is an architecture of parallel computing.
Right.
And this is a fabulous story. This is those two doctors and a few scientists at Stanford saw that our GPU was programmable and could be used almost like a supercomputer. And they tried to use it, and it was incredibly hard to use. But if they were successful in using it, it delivered extraordinary speedups. And so, in working with them, we decided to take the big plunge that we would make our GPU much, much more like a general purpose processor and could be used for far more than graphics, far more than 3D, that it could be used for general purpose mathematics computing. This morning I spent time with a couple of firms that don't want to be named, where they are using our GPU for options risk analysis, and the speed up is 50 times, 100 times, 200 times faster than a cluster of racks and racks of CPUs. And so the benefit, this benefit that I talked about, we thought about 5 years ago, and we decided to invent this technology called CUDA. It's an architecture. CUDA to us is kind of like the x86 to a microprocessor. It's just an architecture interface. It's the name of the architecture. And so it's made it possible for the GPU to be used for general purpose parallel computing. And it's the reason why CUDA, our GPUs are now in the supercomputer in Japan. CUDA is now being taught in some 50 universities around the world, from Oxford to Harvard to Berkeley.
Here's what you said to the New York Times on September 23rd. We think that the number of people interested in this CUDA technology is in the tens of millions. It is not just here. It is in China and India and Russia and Brazil. Many billions of dollars is our rough estimate for the size of the market.
Yeah, this is really interesting. I think a lot of people thought first that CUDA could be used for these extreme computational needs, but it's true. When you can speed up your computer 100 times, what used to take 60 hours now takes just a couple of hours. What used to be impossible to do, you can now do in real time. The imagination kind of goes wild. And so, whether it's in imaging or movies or film or whether it's for doctors or scientists, all of a sudden, the computer looks very different to you because we've effectively shortened or gave them a time machine, if you will. We showed them how fast a computer without CUDA would be like in 10 years.
Things are not always simple and easy and promising. You've had some losses. You had trouble with a faulty chip. You've had to lay off people. You've had to face, rocky seas.
Yeah. Well, that's Charlie. That's the adversity is an unexpected speed bumps is the price of innovation. Some of the biggest challenges that our company has faced is a result of intuitive decisions we made about what was important to invest in, and we bet the farm behind it, and it turned out to have been much harder than we thought. Because technology doesn't, technology and innovation doesn't always come out in linear ways. And let me give you an example. So, we just talked about how CUDA is going to transform and revolutionize computing, and there's hundreds of thousands of people now who have downloaded CUDA. Universities around the world, researchers around the world, are using CUDA now for real fundamental research. Supercomputers are now putting in GPUs with CUDA into their supercomputers. So we've made a fundamental contribution to computing. Yet the way we got here was this. The first observation that I made 8 years ago, maybe 10 years ago, was that computer graphics, which started in the domain of mechanical design, computer-aided design, if we wanted to push this and enable this medium to get further, we have to make it possible for it to be so flexible that any form of artistic expression was possible, so that you could you wouldn't just render an image, you would render the image with style. So everybody's style would be different. Every video game would be different. Every movie would be different. You could look at a movie and go, you know what? That's Spielberg's style. Okay, that's his look. That's his signature. And so, in order to make that possible, in order to make that possible, we had to make our GPU programmable. Our first attempt at programmability was very, very challenging for us, and it said, you know, people said that Nvidia lost their edge, but it wasn't true at all. It was because we took a chance, and the technology turned out to have been too expensive. Shortly after that, the company and the industry, as a result, became much larger. So we took a step back as a company, but when we finally got it right, we expanded the reach of our industry dramatically. Dramatically. The programmability journey was what led to CUDA, to make it possible for this GPU, which was only dedicated for one thing, 3D graphics. Now it could be used for image processing for Adobe Photoshop. It could be used for video processing for Adobe Premiere. It could be used here in Manhattan for computational finance. So all of a sudden, because of that investment, because of that belief that we could make this GPU in companion to the CPU, really accelerate computing, that was a wonderful vision. But along the way, we kind of ran into speed bumps.
All right. When you think about the mountain to climb, I mean, what's the holy grail for people who create GPUs, who have been a critical part of this explosion of visual computing?
My holy grail and our holy grail as a company is to make a difference. You know, to have created technology that or capabilities that frankly surprises you or delights you. You know, you could imagine that someday Nvidia's technology augments reality somehow. You know, partly real, partly computer graphics, and so how would you use that for? Well, one of my favorite applications that I hope we continue to advance is augmented reality for the car, so that someday your car, your windshield is no longer just a piece of glass, but it's a piece of computer glass like this. And instead of just seeing what you see, we actually augment it with computer graphics on top to enhance your vision, if you will.
Thank you for coming to my table.
Charlie, it's a great pleasure to be here.